The way that we go about teaching multiplication is to show students that multiplication equations can be arranged in arrays. So, for example, 2 times 3 is a 2 by 3 array, equaling a total of 6, or 2 equal groups of 3, or 3 equal groups of 2. We take that concept and we transfer it to a larger scale by having students use base 10 grid paper. Students understand that this larger square within this base 10 grid paper is equal to 100. This little square is a unit, and the strip is a 10, and a 10 by 10 equals 100. So that by doing that, we can multiply larger numbers using a conceptual model. So for example, the number 22 times 17 can be displayed as a 10, and 2, 10, 10, 2, or 22, by 17, which is a 10, and 7. And we teach students to go ahead and turn that shape into an array. And then students are asked to look at the pieces within this array. So here, we have 100. Here we have 100. Here we have, 10 times 7, or 70. Here we have another 10 times 7, or 70. Here we have the 2 by 10, which is 20. Here we have a 2 by 7, which is 14 units. And then students are asked to look at those different pieces and add them up, all those partial products. So we have 100 plus 70 equals 170. Another 100 plus 70 equals another 170. And 20 plus 14 equals 34. 4, 17, 374. Students can then look at that and double check it by using the standard algorithm. 22 times 17 is 7 times 2 is 14. I can lay the 4 down and I carry the 10 ones up to the 10 side. And then 7 times 2 is 14, plus that 110 makes it 15, 154. Then I lay the 0 down because we are no longer using the 7 in the ones place. We're using the 1 in the tens place, essentially making this 10 times 2, which would be 20. But since we're thinking of it as single digits, 1 times 2 is 2, and 1 times 2 is 2. I'm done with that. Add up my partial products. I have 4, 7, 3, and my answer matches.